Here I have a nice number theory problem for the channel. We're asked to prove that when we have a positive integer n squared divides n plus 1 to the n power minus 1. And we're going to use something called binomial expansion here that I'll go ahead and note down right here. So here I have the binomial expansion definition written out. Suppose we have a plus b to the c power. Then a to the c is our first term. Our second term is c choose 1 times a to the c minus 1 times b plus c choose 2 times a to the c minus 2 times b squared plus all the way up to c choose c minus 2 times a squared times b to the c minus 2 plus c choose c minus 1 times a times b to the c minus 1 plus b to the c. Let's go ahead and look at that in action really quick. We'll expand x plus y cubed, all cubed I should say, and we'll use this binomial expansion. So our a is x, our b is y, and our c is 3. So we'll have x cubed plus, and we'll just leave this as 3 choose 1 for now, and I'll show you what that means in a moment. And then we'll have a, that's our x, to the c minus 1, so that'll be x squared times b, but our b is y, plus c choose 2, so that's 3 choose 2. And then we'll have x, that is 3 minus 2, so c minus 2, that's 3 minus 2, so that's 1. And then y squared. And then we're done, so our last term is y cubed. Now let's get into what this choose term means. 3 choose 1 is equal to 3 factorial over 3 minus 1 factorial times 1 factorial. So in this case, 3 factorial is 3 times 2 times 1. 3 minus 1 factorial is 2 times 1, and then 1 factorial is just 1. So this bottom cancels with 2 times 1 on the top, and we're just left with 3. So 3 choose 1 is 3 here, so we'll have x cubed plus 3x squared y. And then 3 choose 2, we will replace this term here with 3 minus 2 factorial, and then this term becomes 2 factorial. So now this turns into 3 times 2 times 1 on the top. That part stays the same. But then the bottom becomes 3 minus 2 factorial, that's 1 factorial, times 2 factorial, but that's 2 times 1. And just like before, the bottom cancels with this 2 times 1 on the top, and we're left with 3. So we have 3xy squared plus y cubed, which we know to be this term just expanded out. So now that we've kind of defined binomial expansion, we're going to use it on this n plus 1 to the n term and see what we get. And that'll lead us to where we want to go in our proof. So let's do that. Okay, so like I said before, we're going to want to use this binomial expansion to expand n plus 1 to the n. So first we'll get n to the n here. That's this first term. But then we'll get n to the n minus 1 times 1. We'll also want to add our n choose 1 term. That's this c choose 1 term here, where our c is just n being the exponent, not this n down here. And then we'll have n to the n minus 2 times 1 squared, but that's still just 1. And then we'll have n choose 2 here. And then we'll continue this on all the way up to n to the n minus 1. So that's just the n to the 1 power term, but I'll just leave it like that for now to kind of show where we're going. And then we'll have n choose n minus 1 here. And again, that's like 1 to the n minus 1 power, but that's still equal to 1. So I just kind of drop that term out here. But then we'll have 1 here as our last term, which means that we only need to test this term here because that's our n to the 1 power term. Everything else has an n squared inside it. So n to the 1 power times n choose n minus 1 needs to have an n squared inside it, otherwise this doesn't work. So let's test what this might be. N choose n minus 1 is going to be n factorial over n minus 1 factorial times n minus 1 factorial, like so. So this bit here just becomes 1 factorial, So we can get rid of that because that's just going to be dividing by 1, so that doesn't really matter. All we're worried about is n factorial over n minus 1 factorial, but that's going to give us n. But we already have an n here, so that means we have n times n, which is equal to n squared. So all of these terms have an n squared inside them outside of this 1 here. So now that we've shown that, let's bring that up to the top and we'll finish this proof off. So in the last board, we showed that this n plus 1 to the n expands such that all terms have n squared inside of them, except for the last term, which is 1. So when we take that expansion, we'll say n to the n plus n to the n minus 1 times n choose 1 plus n to the n minus 2 times n choose 2 all the way down to n to the 1 times n choose n minus 1 plus 1. That's this binomial expansion of n plus 1 to the n. Minus 1, that's this minus 1 here, is equal to n to the n plus n to the n minus 1 times n choose 1 all the way down to n squared. That's this term here, and we proved that that term is n squared down on the last board. But that means that all of these terms have an n squared, so we can factor that out, and we'll get n squared times n to the n minus 2 plus n to the n minus 3 times n choose 1 all the way down to 1. That's this n squared term with n squared pulled out. And so here we've shown that n squared divides n plus 1 to the n minus 1. And that's enough for now.